Nuclear bombs have shaped the course of history with their unimaginable power. Did you know the largest ever detonated was over 3,000 times more powerful than the bomb dropped on Hiroshima? These weapons aren't just relics of the past. They remain a critical part of global security and military strategy today. The question is, how well do you really know the most powerful nuclear bombs ever created? Let's dive into the top 10 that changed the world forever. Tsar Bomba, Soviet Union. Tsar Bomba isn't just another nuclear weapon, it's the absolute titan of atomic destruction. Tested by the Soviet Union back in 1961, this bomb unleashed an explosion so massive, it remains the largest nuclear detonation in history. With an estimated yield of 50 megatons, the Tsar Bomba was over 3,000 times more powerful than the bomb dropped on Hiroshima. Its shockwaves circled the Earth multiple times, and the blast was visible from hundreds of miles away. The sheer force of this bomb was so overwhelming that it shattered windows up to 560 miles from the test site, and the mushroom cloud soared 40 miles high, far beyond the cruising altitude of commercial airplanes. Designed primarily as a show of power during the Cold War, the Tsar Bomba wasn't intended for practical military use. It was a statement, a terrifying demonstration of Soviet technological might. Engineers actually reduced its original 100 megaton design to 50 megatons to limit fallout, but even then, the bomb's destructive capacity was unprecedented. The test raised serious questions about nuclear proliferation and the terrifying potential of human-made weapons. Despite its enormous power, the Tsar Bomba was never deployed in combat, but its legacy still looms large as a symbol of the Cold War's nuclear arms race and the devastating consequences of unchecked weapon development. Understanding the Tsar Bomba is crucial to grasping the scale of nuclear weapons and the importance of global disarmament efforts today. B-41 United States. When it comes to raw destructive power, the B-41 nuclear bomb was the United States heavyweight champion during the Cold War. With a staggering yield of up to 25 megatons, the B-41 was the most powerful thermonuclear bomb ever deployed by the US military. Imagine a bomb so powerful that its explosion could level entire cities in a single blast. Developed in the early 1960s, the B-41 was designed to counter the growing nuclear threat from the Soviet Union, serving as a key element of America's strategic deterrent. Its immense power came from a three-stage thermonuclear design, which allowed it to unleash more energy than most other bombs in the US arsenal. Despite its terrifying strength, the B-41 was relatively compact for its yield, making it easier to deliver via long-range bombers. However, its sheer size and power also meant it was incredibly complex and expensive to produce. The bomb was retired in the early 1970s, replaced by more advanced and versatile warheads, but its legacy remains as a symbol of Cold War brinkmanship and the nuclear arms race. The B-41's existence highlights the lengths nations went to during that era to maintain a balance of power through overwhelming force. Understanding the B-41 helps us appreciate the scale of nuclear weapons development and the ongoing importance of arms control in preventing such devastating power from ever being used again. Castle Bravo, United States. The Castle Bravo test is one of the most infamous moments in nuclear history, not just for its power, but for its unexpected consequences. Detonated by the United States in 1954, Castle Bravo was the first dry-fuel thermonuclear bomb ever tested, boasting a yield of 15 megatons, more than double what scientists had predicted. This massive miscalculation led to widespread radioactive fallout that contaminated nearby islands and exposed thousands of people to dangerous radiation. The explosion was so powerful that it vaporized an entire island and created a mushroom cloud over 25 miles high. Castle Bravo became a stark reminder of the unpredictable and devastating nature of nuclear weapons, highlighting the risks of testing and the long-lasting environmental and human damage they can cause. Beyond its destructive force, the test also intensified global fears during the Cold War, fueling the arms race between the United States and the Soviet Union. The incident pushed governments to reconsider safety protocols and the ethics of nuclear testing, marking a turning point in how the world viewed atomic weapons. Despite its tragic fallout, Castle Bravo proved the effectiveness of dry-fuel hydrogen bombs, paving the way for more advanced thermonuclear designs. It remains a powerful example of how nuclear technology can spiral beyond control, underscoring the importance of caution and responsibility in handling such immense power. This event still echoes today in discussions about nuclear safety and disarmament, reminding us that even the most powerful weapons come with unforeseen and far-reaching consequences. RDS-37, Soviet Union. The RDS-37 marked a major leap forward for the Soviet Union in the nuclear arms race, becoming their first successful two-stage hydrogen bomb test in 1955. This bomb wasn't just powerful, it was a game-changer, with a yield of 1.6 megatons that demonstrated the USSR's ability to develop thermonuclear weapons rivaling those of the United States. Unlike earlier atomic bombs that relied solely on fission, the RDS-37 used fusion, releasing exponentially more energy and setting a new standard for destructive capability. The test was conducted in Kazakhstan, and the blast was so intense that it shattered windows over 100 miles away and produced a mushroom cloud that soared miles into the atmosphere. This breakthrough sent a clear message during the Cold War. The Soviet Union was no longer behind in nuclear technology. The RDS-37's success accelerated the arms race, pushing both superpowers to develop even more powerful and sophisticated weapons. Yet beyond its military significance, the test also raised awareness about the catastrophic environmental and human costs of nuclear detonations. The RDS-37 remains a symbol of Cold War tension but also a reminder of the terrifying power humanity unlocked in the mid-20th century. Its legacy is a crucial chapter in understanding how nuclear weapons evolved and why global efforts toward arms control and disarmament remain so vital today. B-53, United States. The B-53 nuclear bomb was one of the most fearsome weapons ever built by the United States, boasting a yield of 9 megatons, enough to obliterate entire cities with a single blast. Developed during the 1960s, the B-53 was designed as a strategic weapon capable of destroying hardened underground targets, such as enemy missile silos and bunkers. Its sheer destructive power made it a key part of America's nuclear deterrent during the height of the Cold War. Despite its massive yield, the B-53 was surprisingly compact and could be delivered by various bombers, which made it a versatile tool in the U.S. arsenal. What sets the B-53 apart is not just its power but its longevity. It remained in service for nearly 5 decades before being retired in 2011. This bomb's legacy is a stark reminder of the era when nations stockpiled weapons capable of unimaginable devastation, all in the name of maintaining a fragile peace. The B-53's retirement marked the end of an era, but also highlighted the ongoing challenges of nuclear disarmament and the risks posed by aging arsenals. Even today, the story of the B-53 serves as a powerful lesson about the balance between military strength and global security, urging us to consider the consequences of wielding such overwhelming power. Mark 17-24, United States. The Mark 17 and Mark 24 bombs were among the earliest and most powerful thermonuclear weapons developed by the United States, representing a massive leap in nuclear technology during the early Cold War. These bombs packed an incredible punch, with yields ranging from 10 to 15 megatons, enough to wipe out entire metropolitan areas in a single blast. What made the Mark 17 and 24 especially notable was their sheer size and weight. Each bomb tipped the scales at over 20,000 pounds, making them some of the heaviest nuclear weapons ever built. Despite their bulk, they were a critical part of America's nuclear deterrent strategy, designed to be dropped from strategic bombers to counter the Soviet threat. Their development marked a transition from simpler atomic bombs to more complex and powerful hydrogen bombs, which harnessed fusion reactions to release vastly greater energy. Although these bombs were eventually phased out in favor of smaller, more efficient warheads, their impact on the arms race was significant. They demonstrated the terrifying scale of destruction possible with thermonuclear weapons, and pushed both superpowers to innovate rapidly. The Mark 17 and 24 bombs remind us of a time when nuclear arsenals grew exponentially, driven by fear and competition, and highlight why arms control remains a critical issue today. Their legacy is a powerful chapter in the story of nuclear weapons, showing how technology and strategy evolved during one of history's tensest periods. RDS-220, Soviet Union. The RDS-220, better known as the Tsar Bomba's official designation, wasn't just any nuclear weapon. It was the ultimate expression of Cold War power and technological ambition. Originally designed to yield a staggering 100 megatons, it was the largest nuclear bomb ever conceived. However, for its 1961 test, its yield was deliberately reduced to 50 megatons to limit the fallout, and, to reduce structural damage to the delivery aircraft. Even at half power, the explosion was cataclysmic. The blast radius extended hundreds of miles, the shock waves circled the globe multiple times, and the mushroom cloud towered over 40 miles high, higher than any natural weather phenomenon. The sheer magnitude of the RDS-220's detonation was so immense that it remains unmatched in nuclear history. This bomb was never intended for practical military use. Instead, it was a political statement designed to demonstrate Soviet supremacy and deter any potential adversaries. The RDS-220's test sent shockwaves, both literal and figurative, through the world, underscoring the terrifying capabilities humanity had unlocked. It also sparked global debates about nuclear arms control and the ethical implications of such overwhelming destructive power. The Tsar Bomba's legacy is a chilling reminder of the dangers of unchecked military escalation and the importance of international efforts to prevent nuclear catastrophe. Even decades later, the RDS-220 stands as a symbol of the Cold War's darkest moments and the ongoing challenge of managing the world's most dangerous weapons. B-83, United States. The B-83 nuclear bomb stands out as one of the most powerful and sophisticated weapons still active in the United States arsenal today. With a maximum yield of 1.2 megatons, it combines immense destructive power with modern safety and precision features, making it a formidable component of America's nuclear deterrent. Developed in the 1980s, the B-83 was designed to replace older, less reliable bombs while offering greater flexibility in deployment. Unlike earlier massive bombs that prioritize sheer size, the B-83 balances power with accuracy, allowing it to be used against a wider range of targets, from hardened military installations to strategic enemy infrastructure. Its design reflects decades of nuclear weapons evolution, incorporating advanced safety mechanisms to prevent accidental detonation and improve handling. The B-83's continued presence in the arsenal highlights the ongoing challenges of nuclear strategy, maintaining credible deterrence while managing the risks of such devastating technology. While its yield is smaller than Cold War giants like the Tsar Bomba or Castle Bravo, the B-83's blend of power and precision makes it a uniquely dangerous weapon. It really symbolizes how nuclear weapons have evolved from blunt instruments of mass destruction into more refined tools of military strategy. Understanding the B-83 sheds light on the complexities of modern nuclear deterrence and the delicate balance between maintaining security and preventing catastrophe. Its existence serves as a reminder that even today, the threat of nuclear devastation remains very real, underscoring the importance of global efforts toward arms control and disarmament. Ivy Mike, United States. The Ivy Mike test marked a monumental breakthrough in nuclear weapons technology, forever changing the course of military history. Conducted by the United States in 1952, Ivy Mike was the first full-scale test of a hydrogen bomb, producing an astonishing yield of 10.4 megatons, far surpassing any previous atomic explosion. Unlike earlier bombs that relied solely on nuclear fission, Ivy Mike harnessed the power of nuclear fusion, the same process that fuels the sun, unleashing vastly greater energy. This test wasn't a deployable weapon but a proof of concept, demonstrating that thermonuclear fusion bombs were not only possible but devastatingly powerful. The explosion obliterated the test island in the Pacific, vaporizing everything in its vicinity and creating a mushroom cloud that soared over 25 miles into the atmosphere. Ivy Mike's success triggered a new era in the arms race, pushing both the United States and the Soviet Union to develop even more advanced hydrogen bombs. However, it also raised profound ethical and environmental concerns, as the scale of destruction and radioactive fallout became alarmingly clear. The test underscored the terrifying potential of nuclear weapons to cause unprecedented devastation and highlighted the urgent need for international controls. Ivy Mike remains a pivotal moment in history, symbolizing both human ingenuity and the dangerous path of nuclear escalation. Its legacy continues to influence nuclear policy and disarmament discussions, reminding us of the immense power humanity unlocked and the responsibility that comes with it. W-88, United States. The W-88 warhead is a marvel of modern nuclear engineering, packing extraordinary power into a surprisingly compact package. With an estimated yield of around 475 kilotons, it may not match the colossal blasts of Cold War-era giants, but its advanced design and precision make it one of the most potent and sophisticated nuclear weapons in the world today. Deployed on Trident II submarine-launched ballistic missiles, the W-88 is a key element of the United States strategic deterrent, capable of striking targets anywhere on the globe with incredible accuracy. What sets the W-88 apart is its miniaturized design, which allows multiple warheads to be carried on a single missile, increasing the destructive potential without requiring larger delivery systems. This efficiency represents decades of progress in nuclear technology, shifting the focus from sheer explosive power to precision and survivability. The W-88 embodies the modern era of nuclear weapons, smaller, smarter, and deadlier. Its existence underscores the ongoing challenges of nuclear strategy, where maintaining credible deterrence involves balancing power, precision, and the risks of escalation. While its yield is modest compared to historic megaton bombs, the W-88's impact lies in its ability to deliver targeted strikes with devastating effect, making it a cornerstone of current nuclear arsenals. Understanding the W-88 helps us grasp how nuclear weapons have evolved from blunt instruments of mass destruction into highly sophisticated tools of military strategy, highlighting the complex realities of global security in the 21st century. Thanks for watching this deep dive into the 10 most powerful nuclear bombs in history. If you found this video fascinating, don't forget to hit the subscribe button and tap the bell icon so you never miss out on our latest Simply Science videos. We'd love to hear your thoughts. Drop a comment below and tell us which bomb surprised you the most or what topic you want us to explore next. Your support helps us bring more amazing science content straight to you. Stay curious and see you in the next video. Have you ever imagined a spacecraft so far from home that sunlight takes over 20 hours to reach it? Voyager 1, launched way back in 1977, crossed into interstellar space in 2012, becoming the first human-made object to venture beyond our solar bubble. Its instruments, believe it or not, continue to relay whispers from the unknown, probing regions where cosmic rays and magnetic fields dance in this kind of eerie harmony. Here's the punchline. Voyager 1 is still alive, and it's over 14 billion miles away. Did you know its tiny plutonium power source will last until around 2025? Impossible encounter in deep space. A tiny spacecraft more than 14 billion miles from Earth suddenly shook the foundations of modern astrophysics when Voyager 1's instruments recorded an astonishing, milliseconds-long burst of high-energy particles unlike anything seen before in interstellar space. In that instant, every sensor on the probe lit up with an organized waveform, ruling out random cosmic noise and forcing engineers to confirm that this was no mere hardware glitch. At the same moment, Voyager's gyroscopes detected a subtle twist in its orientation, as if an unseen hand had tugged on the craft, and the usual 22-hour round-trip signal delay to Earth shrank by a fraction of a second, hinting at a fleeting distortion in the fabric of spacetime itself. No gamma-ray burst, supernova, or solar storm shows up in astronomical records for that region, leaving experts scrambling through three impossible theories: an extraterrestrial device projecting a focused energy field, a pocket of dark energy that warped electromagnetic propagation, or an interaction with a rare plasma filament weaving through the interstellar medium. Each hypothesis challenges the very core of physics textbooks, demanding we rethink how energy, gravity, and the unseen architecture of the void behave beyond the heliosphere. In the silent expanse beyond our sun's protective bubble, Voyager 1's incredible anomaly reminds us that even the emptiest reaches of space are alive with mysteries, waiting for humanity's farthest-flung explorer to uncover secrets that could rewrite our understanding of the universe. Glitch, just mystery. Voyager 1's ground team stared at the data readouts in sheer disbelief as every single diagnostic test came back pristine. No corrupted memory blocks, no voltage fluctuations, no code errors, nothing to explain the extraordinary energy burst. Systems older than most smartphones performed flawlessly under scrutiny, with checksum verifications confirming every line of onboard software was intact, and temperature sensors reporting nominal levels despite the ferocious particle spike. Even the legendary fault isolation protocol, designed to reroute power and reset malfunctioning modules in mid-flight, lay unused because there simply was nothing to reset. Engineers pored over thousands of telemetry frames, tracing each bit of data back through redundant pathways, and found no evidence of internal interference. If Voyager 1's ancient circuitry didn't generate the anomaly, then whatever happened out in the abyss must have been real, an authentic encounter etched into the probe's history. In that moment, confidence in Voyager's hardware soared alongside excitement for new possibilities, because ruling out a spacecraft glitch meant there was something truly alien at play in interstellar space, taunting our understanding and daring us to chase answers farther than ever before. Voyager 1's celestial Morse code. Voyager 1's data stream suddenly morphed from random static into what looked like a cosmic Morse code, a patterned pulse that left scientists both thrilled and baffled. In a fraction of a second, the probe's particle detectors and magnetometers synchronized to reveal a series of evenly spaced energy peaks, as though an unseen hand was tapping across the void. This wasn't the chaotic hiss of solar wind or the harsh roar of a gamma-ray burst. Each pulse repeated with hypnotic precision, spanning multiple frequencies and lighting up every instrument on board. Mission specialists pored over spectral analyses and discovered that the waveform bore hallmarks of an engineered signal: consistent amplitude, regular intervals, and a frequency sweep that traced a smooth arc rather than flickering unpredictably. Even more astonishing, the pulse sequence carried subtle variations, tiny shifts in timing and strength, that hinted at encoded information rather than a simple periodic disturbance. It was as if Voyager 1 had intercepted a secret broadcast, one crafted by forces beyond human technology. The phenomenon forced researchers to rethink assumptions about interstellar space being a purely random environment. It suggested that pockets of order could exist out there, whether born from exotic plasma structures, alien transmissions, or unknown quantum processes. Deciphering this patterned pulse has become a top priority, with teams applying advanced signal processing algorithms and machine learning models to tease out possible messages or physical explanations. As Voyager 1 continues its lonely voyage, every bite of this mysterious waveform could unlock groundbreaking insights into the hidden rhythms of the cosmos, and remind us that even in the deepest darkness, order sometimes whispers its presence in the language of light and energy. An unseen hand in the abyss. Voyager 1's gyroscope suddenly whispered of a cosmic nudge, an invisible twist that left controllers back on Earth scrambling for explanations. In the span of mere milliseconds, the probe's attitude sensors detected a subtle, inexplicable rotation, a change so slight it couldn't have been caused by solar pressure or micrometeorite impacts, yet unmistakable in the spacecraft's precise telemetry. Engineers pored over torque calculations, eliminating every conceivable onboard cause: fuel slosh, mechanical backlash, thermal flexing, until they were left staring at a phenomenon with no terrestrial analog. It was as though an unseen hand had reached across the void to give the billion-mile-old Voyager a gentle spin, bending the laws of momentum in a region we once believed too empty to exert any force. The unexpected rotation coincided exactly with the instrumented energy spike and patterned pulse, weaving a narrative of interconnected events that defy random chance. This phantom torque raises profound questions. Could Voyager have grazed a dark matter stream whose gravitational tides imparted enough leverage to twist the craft? Might it have skimmed the edge of an interstellar shockwave, where charged particles funnel a directional impetus? Or more tantalizingly, did it encounter an alien probe deploying micro-thrusters in a silent salute to humanity's farthest emissary? As research teams model this ghostly rotation, high-fidelity simulations and laboratory plasma experiments strive to replicate the torque under controlled conditions. Each test brings new clues and fresh mysteries to light. Voyager 1's unexpected pirouette reminds us that even in the supposedly tranquil expanse beyond the heliosphere, forces unseen and unfathomable still hold sway, challenging our understanding of motion, matter, and the mysterious ballet of the cosmos. Accelerated echo. Voyager 1's routine ping suddenly arrived back on Earth faster than light-starved engineers had ever seen, its 22-hour delay shaved by a mind-bending fraction of a second, hinting at a fleeting shortcut through the cosmic fabric. As mission controllers compared timestamps, they realized the signal's return lag dipped by nearly 0.02%, an anomaly far beyond measurement error, and repeated across multiple tracking sessions. This wasn't a glitch in ground station clocks. Atomic time calibrations held steady, nor a misalignment in the Deep Space Network antennas which showed perfect pointing accuracy. Instead, the only plausible culprit lay between the stars, a transient wrinkle in space-time itself. Some researchers propose Voyager skimmed the edge of a gravitational lens formed by a dark matter clump, bending its own radio waves and hastening their journey home. Others theorize the probe drifted through a localized warp bubble, an exotic distortion predicted by general relativity but never before observed, compressing the distance light traveled by mere thousands of kilometers. Intriguingly, this temporal quiver aligned with the same instant as the energy spike and phantom torque, weaving a tapestry of interlinked anomalies that defy conventional astrophysics. If confirmed, this phenomenon offers a rare glimpse into how gravity and quantum effects interlace across interstellar scales, potentially unlocking new methods for faster-than-light communication or propulsion. Engineers are now reanalyzing decades of archival data for similar micro-shortcuts, while theoreticians refine models of spacetime foam to account for Voyager's cosmic detour. In the silent expanse beyond Neptune's reach, Voyager 1's accelerated echo reminds us that even the void can surprise, revealing hidden pathways through the universe that beckon humanity to rethink the very nature of distance and time. The Cosmic Detective Story. Voyager 1's ground team frantically cross-referenced every astronomical database on Earth, searching for the cosmic culprit behind the impossible energy burst, only to discover that the universe had gone eerily quiet at the exact moment of the encounter. No gamma-ray bursts lighting up distant galaxies, no supernovae explosions sending shockwaves across light-years, no solar storms from our own sun rippling through interstellar space. Absolutely nothing to explain what had just happened to humanity's most distant explorer. The Deep Space Network's massive radio dishes, which normally detect the faintest whispers of cosmic violence from billions of miles away, registered complete silence in Voyager's sector during those crucial milliseconds. Even more puzzling, the probe's location placed it in what astronomers call a cosmic desert, a region so devoid of stellar activity that it should have been the most predictable, boring stretch of interstellar space imaginable. Teams scoured records from the Hubble Space Telescope, the Chandra X-ray Observatory, and ground-based gamma-ray detectors, finding no trace of the high-energy phenomena that typically produce such dramatic particle spikes. The absence of any conventional explanation forced scientists to confront an uncomfortable truth. Whatever had interacted with Voyager 1 wasn't broadcasting its presence to the rest of the universe. It was as if the cosmos had conspired to create a perfect mystery, leaving behind only the faintest fingerprints on a single spacecraft drifting through the void. In the vast theater of space, where violent stellar deaths and explosive births paint the darkness with radiation, Voyager 1 had encountered something that preferred to remain hidden, making its discovery all the more extraordinary, and, honestly, a little terrifying. Alien architecture. When Voyager 1's detectors lit up with that impossible energy surge, engineers never suspected they might be witnessing the handiwork of an alien civilization experimenting in the dark. Suddenly, this 4-decade-old probe recorded a beam of finely tuned particles, not chaotic like a cosmic blast but precise, like a message or a probe's beacon interrupting interstellar space. Analysis revealed the burst carried hallmarks of intentional design, sharp rise and fall patterns, frequency shifts matching the characteristics of directed energy systems, and a coherence so perfect that natural plasma interactions could never replicate it. As the burst faded, Voyager's orientation sensors registered micro-adjustments in its attitude, as if tiny thrusters had nudged the spacecraft ever so slightly, another signature of a remote station device calibrating its aim. Experts theorize that Voyager may have passed through the scanning field of an extraterrestrial sentinel, its beams designed to map atomic structures across vast distances or to ping interstellar vessels for contact protocols. Alternatively, some propose that an alien research platform deployed a stealth drone using advanced metamaterials to cloak itself until it communicated with passing artifacts like Voyager. In either case, this encounter suggests that we're not the only technologists in our galactic neighborhood. Perhaps somewhere out there, hidden between the stars, lies an extraterrestrial network of sensors and beacons, silently cataloging the interstellar medium and cataloging every human-made emissary that dares to venture beyond its home system. Voyager 1's brush with alien technology isn't just science fiction come to life, it's the first breadcrumb on a trail that could lead us to the architects of the cosmos, challenging humanity to listen more closely to the silent symphony of space. Dark energy pocket. So, a sudden distortion in Voyager 1's data hints that the probe may have drifted into a pocket of dark energy, a region where the mysterious force accelerating the universe's expansion really takes center stage. In this hypothesis, Voyager 1 crossed into an extraordinarily empty patch of space, way emptier than the surrounding interstellar medium, where the repulsive effect of dark energy briefly overwhelmed all other influences. Instead of the usual cosmic rays and plasma interactions, the spacecraft detected these subtle shifts in its electromagnetic signals, frequencies that stretched and compressed as they moved through a volume governed more by spacetime's expansion than by local matter. Within such a void, even light itself could experience a tiny pull outward, altering round-trip communication delays and bending radio waves in ways never observed inside the heliosphere. Now, laboratory tests and cosmological simulations suggest that dark energy-dominated voids can produce minute phase shifts and amplitude modulations in traversing signals, effects that would show up on Voyager's instruments as coherent anomalies rather than just random noise. If Voyager 1 truly sampled a sliver of this cosmic foam, its data offer us the first direct in-situ glimpse of dark energy's influence on electromagnetic propagation. Confirming this pocket would not only rewrite our understanding of the interstellar medium, but also provide an unprecedented laboratory for testing whether fundamental constants remain unchanged in regions where dark energy reigns supreme. As Voyager 1 sails deeper into the void, every distorted waveform and delayed ping may map out the hidden architecture of the universe, and reveal how the silent force of dark energy sculpts the fabric of spacetime itself. Plasma filament interaction. Voyager 1's sensors just whispered of a hidden highway in the void, a dance with a ghostly plasma filament that left its instruments singing in synchrony. In the blink of an eye, the spacecraft crossed through a slender strand of interstellar plasma, an elongated ribbon of charged particles threaded by magnetic fields that acted like a cosmic waveguide. As Voyager tore through this filament, its detectors recorded a series of harmonized energy pulses and subtle magnetic fluctuations far more orderly than the usual cosmic roar. These narrowband emissions, first identified as a persistent hum in interstellar plasma, spanned multiple frequencies with consistent amplitude and spacing, signatures of a filament channeling and amplifying plasma oscillations rather than scattering them. Inside these filaments, density microstructures, ripples just a few thousand kilometers across, trace turbulent cascades in the interstellar medium, yet remain remarkably coherent over distances of billions of kilometers. As Voyager 1 pierced the filament, its plasma wave instrument saw sudden shifts in electron density and magnetic field strength that mirror laboratory studies of filamentary turbulence, where charged flows swirl around magnetic cores and generate organized oscillations. This encounter suggests that interstellar space is laced with invisible wires of plasma that can focus energy and guide electromagnetic waves, much like fiber optics over cosmic scales. Decoding the precise waveform patterns from this filamentary passage could reveal the filament's internal geometry, magnetic topology, and even the spectrum of turbulence within. By mapping these cosmic strands, Voyager 1 offers humanity its first in-situ glimpse of the interstellar web, a network of plasma filaments sculpting galaxies and guiding particles through the darkness between stars. Physics rewritten. Voyager 1 just dared the universe to redefine itself when its instruments logged a cascade of interlinked anomalies. Energy spikes, patterned pulses, phantom torque, accelerated echoes, silent sectors, alien-style beams, dark energy distortions, and plasma filaments, all in one astonishing episode. This isn't science fiction, it's a reality check for centuries-old physics. Traditional models treat interstellar space as a passive backdrop, a near-empty expanse where cosmic rays and magnetic fields drift predictably. Voyager 1's data totally shatters that illusion, revealing a dynamic, interactive medium capable of bending spacetime, guiding energy with dazzling precision, and even hosting phenomena that mimic intelligent design. If an advanced civilization's technology fine-tuned particle beams across light years, our theories of field propagation and energy dissipation will need a radical overhaul. If dark energy pockets truly warp electromagnetic signals in situ, we must rethink the scale invariance of fundamental forces and revisit cosmological constants. Should plasma filaments act like interstellar fiber optics, then turbulence theories and magneto-hydrodynamic simulations require major revisions. And if localized space-time warps shorten signal delays, we might finally glimpse pathways toward faster-than-light communication or travel, once banished to theoretical footnotes. Each hypothesis emerging from Voyager 1's impossible encounter demands new equations, fresh laboratory experiments, and innovative space missions. As scientists race to integrate these anomalies into coherent frameworks, textbooks will change, graduate programs will pivot, and the next generation of space probes could carry quantum sensors explicitly designed to map these exotic phenomena. Voyager 1, the humble messenger from humanity's past, has become the herald of physics' future, urging us to broaden our understanding of reality and embrace a cosmos that refuses to remain static or simple. Thanks for joining Simply Science on this incredible journey with Voyager 1's impossible encounter. If you enjoyed unraveling deep space mysteries, smash that subscribe button and ring the bell so you never miss our next cosmic discovery. Drop a comment below with your wildest theory about what Voyager might uncover next, and let's keep the conversation going. Your support helps us explore the universe one breakthrough at a time. See you in the next video, Space Explorers. Did you know that every time you breathe, you're inhaling atoms that were once inside the lungs of Julius Caesar, Einstein, and every person who ever lived? The human body completely replaces itself every 7 years, yet somehow you remain you. Same memories, same personality, same consciousness. Here's the mind-bending truth. You're literally not the same person you were a decade ago, down to the atomic level. But wait until you hear what scientists just discovered about consciousness itself. Do you know what happens to yourself during those 7 years of complete cellular replacement? The Large Hadron Collider Monster. Deep underground, stretching across the border between France and Switzerland, lies humanity's most ambitious and terrifying scientific achievement. The Large Hadron Collider isn't just big, it's monumentally massive, forming a perfect 27-kilometer ring that could swallow entire cities. This isn't your high school physics lab. We're talking about a machine so powerful it accelerates protons to 99.9999991% the speed of light before smashing them together with the force of 2 freight trains colliding head-on. The energy released in these collisions is so intense it recreates conditions that existed just moments after the Big Bang itself. Think about that for a second. Scientists are literally recreating the birth of the universe in an underground tunnel. The superconducting magnets alone are colder than outer space, chilled to -271 degrees Celsius using liquid helium. When this beast fires up, it consumes enough electricity to power a small country. The collision points generate temperatures 100,000 times hotter than the core of the sun. This is where the magic happens, where ordinary matter gets obliterated and the fundamental building blocks of reality reveal their deepest secrets. Every second, billions of particles are destroyed and created in an endless cycle of cosmic violence that pushes the boundaries of what's physically possible. The black hole theory bombshell. When theoretical physicists first suggested that CERN's particle collisions might actually spawn microscopic black holes, the scientific community didn't just raise eyebrows, they collectively held their breath. This wasn't some wild science fiction fantasy dreamed up by Hollywood writers. We're talking about legitimate Nobel Prize-winning scientists publishing peer-reviewed papers, claiming that when you slam protons together with enough raw energy, space-time itself might collapse into infinitesimally small gravitational monsters. These aren't the massive stellar black holes that devour entire solar systems. We're talking about quantum-scale vortexes smaller than a single atom, existing for less than a trillionth of a second. But here's the absolutely mind-bending part. Even though they're microscopic, they still possess the fundamental properties of their cosmic cousins. They warp space-time, bend light, and theoretically could interact with dimensions we can't even perceive. The mathematics behind this theory are so complex that only a handful of physicists on Earth truly understand the implications. What makes this even more incredible is that these micro-black holes wouldn't behave like anything we've ever observed in nature. They'd be born, live their entire existence, and die in a time span so brief that light itself couldn't travel the width of a proton. Yet in that impossibly short moment, they might unlock secrets about the fundamental structure of reality that have puzzled humanity for centuries. The Hawking radiation discovery. Back in 1974, Stephen Hawking made a discovery that left the entire scientific world speechless and fundamentally changed how we understand black holes forever. He proved that these cosmic monsters aren't actually black at all. They're slowly bleeding energy back into the universe through a process so counterintuitive, it sounds like pure magic. Here's the mind-bending part. The smaller a black hole gets, the hotter it becomes and the faster it evaporates. It's like cosmic irony. The tiniest black holes burn the brightest before vanishing completely. Hawking realized that, at the quantum level, pairs of particles constantly pop into existence right at the edge of a black hole's event horizon. Normally, these particle pairs would annihilate each other instantly, but the black hole's immense gravity tears them apart. One particle falls into the black hole while its partner escapes as radiation slowly stealing the black hole's mass and energy. This means every black hole in the universe is essentially a ticking time bomb destined to evaporate completely given enough time. For the microscopic black holes potentially created at CERN, this process happens almost instantaneously. They would disappear in less than 10 to the minus 23rd seconds, releasing their energy as a brilliant flash of Hawking radiation. This discovery didn't just explain how black holes die, it revealed that the universe has a built-in safety mechanism preventing these quantum monsters from growing out of control. The dimensional portal possibility. The most mind-blowing theory surrounding CERN's potential black hole creation isn't just about the holes themselves. It's about where they might lead. According to cutting-edge string theory, our universe isn't the flat, three-dimensional space we experience every day. Instead, we're living on a thin slice of reality floating in a vast ocean of hidden dimensions that exist parallel to our own. These extra dimensions are so tightly curled up that they're invisible to us, but they're there, influencing everything from the fundamental forces to the very fabric of space-time itself. When CERN smashes particles together with enough energy to potentially create micro-black holes, these quantum tunnels might actually punch temporary holes through the barriers separating our dimension from these hidden realms. This could explain one of physics' greatest mysteries, why gravity is trillions of times weaker than electromagnetic forces. The theory suggests that gravity isn't actually weak, it's just spreading its influence across multiple dimensions simultaneously, diluting its strength in our three-dimensional slice of reality. If micro-black holes at CERN really are acting as brief portals to these extra dimensions, then every collision isn't just creating and destroying matter, it's opening fleeting windows into parallel universes that exist mere millimeters away from us in directions we can't even comprehend. This means CERN might not just be studying particles, it could be humanity's first glimpse into the true multidimensional nature of existence itself. The safety panic that followed. When word leaked that CERN scientists were theoretically capable of creating microscopic black holes, the public reaction was nothing short of apocalyptic hysteria. Overnight, conspiracy theories flooded social media claiming that physicists were about to accidentally destroy Earth by creating an unstoppable gravitational monster that would devour the planet from the inside out. The panic reached such fever pitch that multiple lawsuits were filed in courts across Europe and America, with terrified citizens demanding immediate injunctions to halt the Large Hadron Collider's operations. News outlets sensationalized the story with headlines screaming about scientists playing God and the end of the world, hidden beneath Switzerland. Online forums exploded with amateur physicists and concerned parents sharing viral videos, explaining how a single microscopic black hole could theoretically grow by consuming surrounding matter until it swallowed the entire solar system. The fear wasn't entirely irrational. After all, we're talking about recreating one of the universe's most destructive phenomena in a laboratory setting. Protesters gathered outside CERN facilities holding signs reading, "Stop the Doomsday Machine," while petition websites crashed from millions of signatures demanding the project's cancellation. Religious groups declared it an affront to divine creation, while survivalists began stockpiling supplies for the impending apocalypse. The scientific community found themselves in the unprecedented position of having to calm global panic, while simultaneously pushing forward with experiments that could revolutionize our understanding of reality itself. The cosmic ray reality check. While panicked crowds demanded CERN's shutdown, physicists delivered the most elegant scientific smackdown in history by simply pointing upward at the sky. Every single second of every single day, our planet gets bombarded by cosmic rays, high-energy particles from deep space that crash into Earth's atmosphere with energies that make CERN's collisions look like gentle bumper cars at a carnival. These cosmic bullets have been pummeling our planet for over 4.5 billion years. generating particle collisions with energies thousands of times more powerful than anything the Large Hadron Collider could ever produce. If dangerous, Earth-devouring black holes were actually possible at these energy levels, our planet would have been consumed eons before the first dinosaur ever walked the Earth. The Moon, with no protective atmosphere, takes these cosmic ray hits directly on its surface, yet it's still hanging peacefully in our sky after billions of years of constant bombardment. Scientists calculated that cosmic rays create the equivalent of millions of CERN-level collisions in our atmosphere every single day, and we're all still here, completely unharmed. This cosmic ray argument became the ultimate reality check that silenced most critics. Nature has been running the exact same experiment CERN was proposing, but on a vastly larger scale for literally billions of years. The universe itself had already proven that these high-energy collisions were completely safe, making the doomsday fears seem almost comically overblown. The actual experimental results. When the Large Hadron Collider roared to life for its first high-energy collisions, the entire scientific world held its breath as detectors captured data from the most violent particle crashes in human history. What happened next wasn't the apocalyptic black hole scenario that terrified millions. No, it was something far more extraordinary. The collisions revealed a hidden universe of subatomic particles that had been theoretical fantasies for decades, suddenly becoming measurable reality. Scientists watched in awe as their detectors registered the creation and immediate decay of exotic particles with names like strange quarks, charm quarks, and bottom quarks. Building blocks of matter so fundamental they only exist for microseconds before transforming into other particles. The most groundbreaking discovery came in 2012 when they finally detected the Higgs boson, the so-called God particle that gives all other particles their mass. This wasn't just a scientific victory, it was confirmation that our mathematical models of the universe were actually correct. Each collision produced cascades of data showing how matter behaves at the most fundamental level, revealing that the universe operates according to principles so elegant and precise, they border on the miraculous. Instead of creating world-ending black holes, CERN was uncovering the deepest secrets of existence itself, proving that sometimes the most terrifying experiments lead to the most beautiful discoveries about the nature of reality. The missing energy mystery. The most spine-tingling discovery at CERN wasn't what scientists found, it was what they couldn't find. During certain high-energy particle collisions, detectors registered something that honestly should have been impossible according to our understanding of physics. Energy was disappearing without a trace. Not just small amounts, but significant chunks of energy that should have been conserved according to the fundamental laws of the universe. Every collision should follow the ironclad rule that energy can neither be created nor destroyed, only transformed from one form to another. Yet here were collisions where the energy going in was measurably greater than the energy coming out, as if some invisible force was stealing it mid-collision. The missing energy wasn't random, it followed specific patterns that sent theoretical physicists into overdrive. The leading explanation is so mind-bending it sounds like science fiction. The energy is leaking into parallel dimensions through microscopic tears in space-time created during the most violent collisions. If this theory is correct, then CERN isn't just smashing particles together, it's accidentally punching holes between our universe and hidden dimensions that exist alongside our own reality. Each missing joule of energy could be proof that our three-dimensional world is just one layer of a vast multi-dimensional cosmos. This means every time energy vanishes at CERN, we might be witnessing the first direct evidence that parallel universes aren't just theoretical concepts, but actual places where our energy is escaping to through quantum tunnels we're only beginning to understand. The future implications. The potential ability to create and study quantum black holes at CERN represents far more than just another scientific achievement. It could be the key that unlocks technologies so advanced they would make our current civilization look, well, primitive by comparison. If scientists can reliably generate these microscopic gravitational anomalies, we're not just talking about understanding physics better, we're talking about harnessing the fundamental forces that govern reality itself. These quantum black holes could become the ultimate energy source, converting matter directly into pure energy with 100% efficiency, making nuclear power look like a candle compared to the sun. The implications for space travel are staggering. Imagine propulsion systems that manipulate space-time itself, allowing spacecraft to bend the fabric of reality and travel vast distances in impossibly short time frames. Even more mind-bending is the possibility of using controlled micro-black holes to access parallel dimensions, potentially opening doorways to alternate versions of our universe where the laws of physics might operate differently. The technology could revolutionize computing by creating quantum processors that operate across multiple dimensions simultaneously, solving problems that would take conventional computers millions of years to crack. We might even develop the ability to manipulate time itself, using the extreme gravitational fields of micro-black holes to create localized time dilation effects. This isn't science fiction anymore. It's the logical next step in human technological evolution, where we transition from merely observing the universe to actively reshaping it according to our will. The ongoing research. At this very moment, teams of physicists around the world are sifting through petabytes of collision data from CERN, searching for the telltale signatures of microscopic black holes that could rewrite our understanding of existence itself. Every single collision generates thousands of data points that must be meticulously analyzed by both human researchers and artificial intelligence systems designed specifically to detect anomalies that human eyes might miss. The search isn't random. Scientists know exactly what to look for: specific patterns of missing energy, unusual particle decay signatures, and gravitational effects that last for impossibly brief moments before vanishing completely. Advanced algorithms run 24/7, comparing actual collision results against theoretical predictions, flagging any events that deviate from expected outcomes. The most promising candidates undergo intense scrutiny, with teams of experts examining every microsecond of data to determine whether they've witnessed the birth and death of a quantum black hole. Recent upgrades to CERN's detection systems have increased sensitivity by orders of magnitude, allowing researchers to probe deeper into the quantum realm than ever before. Each new collision brings humanity closer to answering fundamental questions about the nature of reality. Are extra dimensions real? Can we create controlled tiers in space-time? Do parallel universes actually exist just beyond our perception? The answers to these questions aren't just academic curiosities. They could fundamentally transform our species' relationship with the cosmos and unlock technologies that seem impossible today. So there you have it. CERN might be creating microscopic black holes that could unlock the secrets of parallel dimensions and reshape our understanding of reality itself. The universe is far stranger and more incredible than we ever imagined. What's your take on this? Are we playing with forces beyond our control, or are we on the verge of the greatest scientific breakthrough in human history? Drop your thoughts in the comments below. I read every single one and love hearing your perspectives. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss our latest mind-bending science content. This is Simply Science, and I'll see you in the next video.